Let's begin by exploring the OSI model from the top down. It's a conceptual framework for thinking about the components of any IT architecture and contains 7 layers. At the top is the application layer. This layer is what the users see and how the users interact with our application. It's somewhat synonymous with the view component of the Model View Controller or MVC design pattern we studied in an earlier course. Next is the presentation layer. This layer defines how data is structured and represented. Is it JSON, XML, or a JPEG image? Is it encrypted or not? What about compression? Those questions are answered here. Below that is the session layer. In a previous course, we discussed authentication tokens and session IDs at a high level. This layer is responsible for maintaining that connection state so users don't have to log in every time they click a box on your website. To move all this data around, the transport layer is used. If you've heard the terms TCP and UDP before, these are transport protocols. We will get into those more later, but basically it's like driving versus flying versus cycling. Each has advantages and disadvantages. Moving down the stack, we encounter the network layer. Decisions made at this layer are called routing decisions and the datagrams are called packets. Layer 3 devices govern the path that traffic takes through a network and the Internet Protocol, or IP, lives at this layer. Deeper still lies the data link layer. Additional data addressing is often needed to deliver the traffic correctly and is required on multi-access technologies like Ethernet. In Ethernet, these are called Media Access Control or MAC addresses, a term you've probably heard before. Layer 2 datagrams are called frames. At the bottom, we have the physical layer. Think about all the ways to transmit data. We can use electricity in copper wires, light pulses in fiber optic cable, radio waves in wireless systems, etc. This layer handles the low-level transmission and reception of data from a variety of media types. When it comes to focus areas, developers writing an app tend to focus on the top 4 layers, which has been the focus of the previous 2 courses. We casually waved away many of the lower-level details while writing our apps. That changes now. Our focus will be on the networker's perspective, which is mostly layer 4 and down. We are essentially road builders now, so try to get into that frame of mind. Let's talk about 4 devices commonly seen in networks. In a previous course, I introduced load balancers. These devices are the target of some application request, such as an HTTP request for a web app. Behind the load balancer are the actual web servers waiting to process the requests. The load balancer forwards requests to these servers based on a variety of parameters such as server health and workload. I like to think of load balancers as operating primarily at the presentation layer. Yes, these devices have IP and MAC addresses, but their contribution to the overall system is session distribution. A firewall is a security appliance that statefully permits and denies traffic across it, kind of like a traffic cop with a photographic memory. If it sees an HTTP request coming from an internal client, it expects to see an HTTP server response in the reverse direction. These are often placed at a network's perimeter as a first line of defense. The firewall's operational role has traditionally been transport protocol filtering. Modern firewalls can filter much higher up in the OSI stack, but let's keep it simple for now. The router makes routing decisions based on a packet's destination IP address. When a packet arrives, the router looks at the network address and decides which way to send the packet. These decisions can be statically configured, dynamically determined by a routing protocol, or centrally programmed by a software-defined controller. As you may have guessed, routers operate at the network layer by inspecting IP addresses and forwarding traffic along a routed path. Last, we have the switch. This device often connects end hosts like laptops, voice over IP phones, and servers. Switching decisions are made based on the MAC addresses that accompany every Ethernet frame. Switches generally don't look deeper into the stack to examine IP addressing, transport protocols, or any of that. Switches operate at the data link layer using MAC addresses for transport across the switched network.